Hello everyone, my name is Jarna Sapkota and welcome to this presentation on Docker security. I'm a bit under the weather, so my voice might sound a little off. In this session, we'll explore the fundamentals of securing Docker containers, which have become an essential part of software engineering and modern DevOps practices. We'll discuss why securing container is critical, identify common vulnerabilities, and walk through the best practices and tools that can help protect your containerized environments. By the end, you should have a practical grasp of Docker security concepts that you can apply to your projects to keep your system safe and resilient. Docker security involves the measures and strategies used to secure all components involved in a containerized setup. This includes securing the Docker host, the images, the containers themselves, and the communication between different containers. Each of these layers represent a potential point of vulnerability, and it is essential to understand how they all interact to create a secure environment. Containers bring significant benefits to software engineering, such as consistency, portability, and isolation, but they also come with security challenges that need to be addressed holistically. Docker security is an ongoing process that evolves with each new deployment, and it's crucial to stay vigilant about each layer involved. Docker environments can be vulnerable in several ways if best practices are not followed. One of the most common vulnerabilities is using outdated or unpatched container images, which can expose known security holes to attackers. Another significant issue is running containers with excessive privileges, such as using the root user, which can lead to severe consequences if the container is compromised. Lastly, network misconfiguration can expose sensitive services to the public internet or allow unauthorized communication between containers. Understanding these vulnerabilities is crucial to take proactive measures in securing your containerized applications. The principle of least privilege is fundamental in Docker security. It means that containers should only be given the permission they absolutely need to perform their tasks. Running containers with root privileges is a major risk because it can allow attackers to gain full control of the host system if the container is compromised. Instead, containers should run with non-root users whenever possible, limiting access to sensitive host resources by ensuring that the required directories and system resources are accessible can further enhance container security. Docker capabilities can also be used to control permissions at a granular level, reducing the risks of unauthorized access. Securing Docker images is a crucial part of container security. The first step is to always use trusted base images from reputable sources such as official Docker Hub repositories. Using unknown or community contributed images without verification can expose your application to security risk. Next, it is important to scan your images for vulnerabilities using tools like Triffy or Claire. These tools can identify outdated software packages and known vulnerabilities, allowing you to fix them before deployment. Finally, regularly updating images ensures that your containers are running the latest, most secure version of software, helping to protect against newly discovered threats. Network security is a key component of Docker security. One effective approach is to isolate your containers into their own network, which helps to prevent unauthorized communication between different containers. Docker allows you to create custom bridge networks that can limit which container can talk to each other. Additionally, encrypting data in transit between containers ensure that sensitive information is not exposed even if someone manages to intercept the communication, limiting external access to only those services that need to be publicly available. Using firewalls and strict access control lists can also help mitigate exposure and reduce the attack surface. Docker's built-in network features like bridge, overlay, and host networking allows you to tailor the network configuration to meet security requirements. So the implication could be severe. An attacker who gains the access to the container running with root privileges could potentially take over the host system, leading to a full breach. To mitigate such risks, it is critical to always run containers as non-root users and follow the principle of least privileges. By reducing the permission granted to each container, we minimize the potential damage if a compromise occurs. The Docker host is the foundation upon which all containers run, making it security crucial. Start by keeping the host operating system up to date with the latest patches and security updates, as vulnerabilities in the host can directly impact all containers running on it. Using minimal operating system distribution such as Alpine Linux helps reduce the number of software packages and the overall attack surface, making it harder for attacker to find entry points. Additionally, restricting SSH access by using strong authentication methods and limiting which IP addresses can connect to the host will make it significantly more challenging for unauthorized users to gain access. Monitoring system logs can help detect any unusual activity that may indicate a breach. Furthermore, securing the Docker daemon itself with TLS ensures that communication between the client and Docker daemon is encrypted and authenticated, preventing unauthorized access. There are several tools available to assist in securing Docker environments. Docker Bench for Security is a script that runs check against your Docker configuration, looking for common security misconfigurations and best practices. Trivy is an excellent tool for scanning container images for vulnerabilities, ensuring that no known security issues are present before deploying containers. Falco is a runtime security tool that monitors the behavior of containers and generates alerts if suspicious activity is detected. By incorporating these tools into your CI/CD pipeline and runtime environment, you can improve your overall security posture and detect potential issues early. Automating security checks through these tools ensures that vulnerabilities are addressed as a part of the development process rather than after deployment. In summary, Docker security involves taking a layered approach to secure the container, image, host, and network. Following best practices like using the principle of least privilege, securing Docker images, and isolating containers network can significantly reduce risk. Utilizing tools like Docker Bench for security, Trivy, and Falco helps make the security process more manageable and allows for continuous monitoring and improvement. Docker security is not a one time effort. It requires regular monitoring, updating, and vigilance to stay ahead of potential threats. With the right practices and tools, you can make sure your containerized applications are as secure as possible. Thank you for watching this presentation on Docker security. I hope you have gained valuable insights into the importance of securing containerized applications and how to apply best practices to keep your system safe. If you have any questions or need further clarification, please feel free to reach out. Securing Docker container is an ongoing effort, but with the right knowledge, it becomes an achievable and rewarding task.